El Niño has returned. On June 11, 2026, the National Oceanic and Atmospheric Administration confirmed that El Niño conditions have formed in the tropical Pacific, and it issued an official advisory. El Niño is the warm phase of a natural ocean pattern that nudges weather all over the world, and this one is still gaining strength. Forecasters expect it to grow through the coming winter, and they give it close to a 2 in 3 chance of becoming a very strong event. What makes this one worth a closer look is the timing. It is settling in on top of a planet that is already running at record warmth, and that pairing could push global temperatures higher still, while tilting the odds toward drought in some regions and heavy flooding in others. If reports like this one are useful to you, you're welcome to subscribe. Over the next 2 hours, this report will walk through how the pattern formed, why the ocean and the wind shifted together, where the effects are likely to land, and what is still uncertain. The big news came quietly, the way these things usually do. Earlier this month, the National Oceanic and Atmospheric Administration looked at the tropical Pacific Ocean and made it official. El Niño had formed. The agency issued what it calls an advisory, which is the plain signal that the warm phase of this Pacific pattern has arrived and is expected to stay. No siren went with it. It was a steady line in a monthly report, written for emergency planners, farmers, and anyone whose week depends on the sky. To see why that line matters, look at what the ocean was doing. The strip of sea that forecasters watch most closely runs along the equator in the central Pacific, far from any coast. In the days around the announcement, the water there was running about 1.5 degrees Celsius above its normal temperature. That is close to 3 degrees Fahrenheit. The number sounds small when you say it out loud. Spread across an ocean that wide and that deep, it is a staggering amount of stored heat, and heat is the fuel that moves weather. The advisory does 2 things at once. It confirms that the warm conditions are present now, and it says forecasters expect them to continue. That second part is the reason a single sentence in a technical update can ripple out to half the planet. When this part of the Pacific warms, it does not keep the change to itself. It changes where rain falls, where it does not, and which way the great rivers of wind in the upper air decide to bend. For now, hold on to one simple picture. A wide band of the equatorial Pacific is warmer than it should be. That warmth is still building, and the people whose job is to watch it have decided it is real enough and lasting enough to put a name on. The name is El Niño. It helps to know who is making the call, because that tells you how much weight to give it. The National Oceanic and Atmospheric Administration is the United States science agency that runs the National Weather Service and tracks the oceans and the atmosphere together. It does not work alone on this. It shares notes with research centres and with weather agencies in other countries, and the major forecasts tend to line up before any of them speak. When several independent groups looking at the same ocean reach the same conclusion, the conclusion is usually sound. In this case, they did. There is a calm honesty built into the way the advisory is worded, and it is worth noticing. Forecasters did not say a disaster is coming. They said a known pattern has shifted into its warm phase, that this raises the odds of certain kinds of weather in certain places, and that the strength and the timing are still coming into focus. That is the right way to hear it. El Niño is not a storm bearing down on a single town. It is a change in the background conditions for the whole globe, a thumb pressed gently on the scale, making some outcomes more likely and others less so over the months ahead. What makes this particular advisory worth a closer look is not just that El Niño is here, it is that El Niño is arriving on a planet that has already been setting heat records on its own. The two are separate things. One is a natural cycle that comes and goes every few years. The other is a long, steady warming. When they overlap, the warm phase can act like a small boost stacked on a rising floor, and the totals can reach places they have not reached before. We will come back to that idea in full later, because it is the heart of why this report exists. So the story starts with a quiet confirmation and a warm ocean. From here, it only makes sense if we slow down and answer the most basic question first. People hear the words El Niño constantly, often tied to whatever went wrong with last year's weather, but the term gets used loosely, and it gets blamed for things it never touched. Before we follow the warmth out across the world, it is worth a few minutes to say plainly what this thing actually is, where the name came from, and what it does and does not control. That is where we turn next, and once it is clear, everything that follows will be easier to hold. El Niño is the warm phase of a natural seesaw in the tropical Pacific Ocean. That is the whole idea in one line, and the rest is detail. The ocean along the equator does not hold a steady temperature year after year. It tips slowly back and forth between a warm side and a cool side, with a calm middle in between. The warm side is El Niño. The cool side is La Niña. The calm middle is what forecasters call neutral. The full swing, taken together, is the pattern that drives more of the world's year-to-year weather changes than anything else we know of. The name is old, and it is local. Centuries ago, fishermen off the coast of Peru and Ecuador noticed that the sea sometimes turned warm around the end of the year, near Christmas. The warm water pushed away the cold, fish-rich currents they depended on, and the catch fell off. They called the warming El Niño, which in Spanish means the boy child, a quiet nod to the season of the year it tended to arrive. For a long time it was treated as a regional curiosity off South America. Only much later did scientists work out that the warm coastal water was the near edge of a change that stretched thousands of miles across the open ocean. The piece that took the longest to understand is that the ocean and the air move together. In the late 1960s, researchers connected two things that had been studied apart. One was the warming of the Pacific. The other was a wide swing in air pressure across the same region. They turned out to be two faces of a single system, the ocean below and the atmosphere above, each pushing on the other. That insight is the reason forecasters now watch the sea and the wind as one machine rather than two separate dials. Here is how the normal, calm state works, because El Niño is easiest to grasp as a break from it. Along the equator, the steady winds usually blow from east to west, from the Americas toward Asia. Those winds drag the warm surface water westward and pile it up near Indonesia and the western Pacific. As the warm water moves off, cooler water rises to take its place along the South American coast. So in a normal year, the western Pacific is warm and rainy, and the eastern Pacific is cooler and drier. That tilt holds the weather in a familiar shape. El Niño is what happens when that arrangement loosens. The east to west winds weaken, and sometimes they reverse. With less wind pushing it west, the warm water slides back toward the center and the east of the ocean. The cool upwelling along South America fades. Now the warmth and the rain that travels with it sits in a different place than usual. The Pacific has not made new heat out of nothing. It has rearranged the heat it already had, and that rearrangement is enough to bend weather patterns far beyond the tropics. A few plain facts keep this in proportion. The pattern is not on a clock. It swings every 2 to 7 years, with no fixed schedule, which is part of why each event still carries some surprise. When an El Niño does form, it usually lasts about 9 months to a year, building over the back half of the year and fading the following spring. And it is a matter of degree, not an on and off switch. A weak El Niño barely registers in most places. A strong one can be felt on nearly every continent. One more caution before we move on, because it is the most common mistake. El Niño does not cause any single storm, flood or dry spell. It loads the dice. It makes some kinds of weather more likely in some regions and less likely in others, and it does this for months at a stretch. A flood that lands during an El Niño year might have happened anyway. What the pattern changes is the odds, season by season, across wide areas. That is what this thing is. The next question is how we knew it was coming this time, and the answer lies in the first warm signals that showed up in the ocean before the announcement was ever made. The first hints did not come from a coastline or a city. They came from a long row of buoys and satellites watching the open equatorial Pacific, the same lonely stretch of sea forecasters care about most. For months, those instruments had been reporting an ocean that was simply average. The water near the equator sat close to its normal temperature, the winds held their usual course, and the pattern was parked in its calm middle state. Then slowly the numbers began to lean. The measurement that matters here is the temperature of the sea surface in that central Pacific zone, compared against the long-term average for the time of year. Forecasters do not ask whether the water is warm in plain terms, because tropical water is always warm. They ask whether it is warmer than it should be for that week, that month, that season. The threshold they use to flag the warm phase is 0.5 degree Celsius above average, which is a little under 1 degree Fahrenheit. Cross that line and stay across it, and you are leaning toward El Niño. Through the first part of the year, the readings crept upward. The 3-month average that forecasters lean on most was still sitting just under the threshold in late spring, close to 0.5 degrees but not quite over it. On paper, that looked like a system still making up its mind. But the weekly snapshots told a faster story. In the most recent weeks before the announcement, the single-week readings had surged well past the line, reaching about 1.5 degrees Celsius above normal. The slow average was lagging behind a Pacific that was warming in a hurry. That gap between the slow number and the fast number is worth pausing on, because it is exactly what a forming El Niño looks like. The 3-month average is built to be patient. It smooths out short bursts so that a single warm week cannot trigger a false alarm. The weekly values are the leading edge. When the weeklies climb far above the threshold and stay there, they pull the patient average up behind them over the following months. Forecasters had seen this shape many times. A warm pulse arriving early, the average climbing to meet it, the system tipping over into its warm phase. It helps to picture where this heat actually was. Imagine a tongue of warmer than usual water stretched along the equator, beginning near the middle of the Pacific and reaching east towards South America. That warm tongue had been faint and patchy. As spring turned towards summer, it filled in and grew more solid. The instruments could see it spreading and deepening, not just at the surface but in the water below, where a reservoir of warmth had been sliding eastward beneath the waves. There is a reason forecasters trust the subsurface as much as the surface. The heat hidden a few hundred feet down is the fuel supply. When a deep pool of warm water moves east along the equator, it tends to surface in the weeks and months that follow, feeding the warm phase from below. By late spring, that underwater warmth was in place. The surface was responding, and the major forecast centres, looking at the same data, had begun raising their odds of El Niño from likely to nearly certain for the months just ahead. None of this happened in a single dramatic moment. That is the honest truth of how these events begin. There was no one morning when the Pacific flipped. There was a long, quiet climb in the numbers, a warm tongue thickening, a deep pool of heat creeping eastward, and a set of forecasts converging week after week until the conclusion was hard to avoid. The advisory, when it finally came, was less a surprise than a confirmation of something the instruments had been spelling out for a while. But warm water is only half of the system, and on its own it is not enough. For an El Niño to truly take hold, the air above has to join in. The ocean can warm, but if the winds keep blowing as they always do, the warmth can fade before it ever locks in. What sealed it this time was the atmosphere finally giving way, the trade winds easing their grip, and that is the part of the story we turn to now. The winds came next, and they are the other half of the engine. An ocean can warm on its own for a while, but a true El Niño needs the atmosphere to agree. Until the air changes its habits, the warm water can drain away and the whole thing can fizzle. What pushed this event from a warm spell into a confirmed pattern was the moment the winds let go. Start with the winds that normally run the show. Along the equator, a belt of steady breezes called the trade winds blows from east to west, year-round, like a slow and reliable current of air. These are the same winds that pile warm surface water against Asia in a normal year. They are not dramatic, they are persistent, and persistence is what gives them their power. Day after day they nudge the ocean, and the ocean obeys. During an El Niño, those trade winds weaken. Sometimes in patches they stop or even turn around and blow the other way. When the steady push from the east eases off, the warm water that had been held in the west is free to slosh back toward the centre of the ocean. The wind and the water are locked in a loop. Weaker winds let the warmth spread east, and the spreading warmth weakens the winds further, each one feeding the other. That loop is the heart of how an El Niño builds and holds. Forecasters track the air side of this with a simple measure of pressure. They compare the air pressure on the western side of the Pacific with the pressure on the eastern side. In a normal year, that difference sits in a familiar range, and the trade winds blow accordingly. When the difference shrinks or flips, it is a sign the winds are faltering, and the warm phase is taking over. In the weeks before this advisory, that pressure measure had swung firmly into the territory that signals a weakening of the usual circulation. The atmosphere was no longer holding its normal shape. There is a name for the big overturning circulation that the trade winds are part of, and it is worth knowing in plain terms. Picture a giant loop of air over the tropical Pacific. air rises over the warm, rainy western side near Indonesia, drifts east high above the ocean, sinks over the cooler eastern side and flows back west along the surface as the trade winds. That loop is the normal engine. El Niño weakens it. The rising motion that used to sit over the far west slides toward the center of the ocean, following the warm water, and the whole circulation goes slack and shifts its position. When the rising air moves, the rain moves with it. This is the link that carries El Niño out into the world. Rain falls where warm, moist air rises, and dries up where air sinks. So as the zone of rising air drifts east toward the middle of the Pacific, the heavy tropical rains drift with it, away from the western Pacific and out over open water. Places that count on that rain can be left dry. Places that are usually dry can find themselves under storms. The ocean rearranged its heat, and now the atmosphere is rearranging its rain to match. By the time the advisory was issued, both halves of the engine were running in the same direction. The sea surface was warm and getting warmer. The trade winds had eased. The pressure measure had swung the right way. The rising air and the rainfall were on the move. This is what forecasters mean when they say the ocean and the atmosphere have coupled. They're no longer two systems drifting on their own. They have locked together into a single pattern that tends to reinforce itself and carry on for months. That coupling is the reason an advisory can be issued with confidence rather than as a guess. One warm reading could be noise. A warm ocean paired with slack winds and shifted rainfall is a system that is committed. Still, committing and meeting the formal definition are not quite the same thing, and there is a careful set of rules that decides when forecasters are allowed to put the name El Niño on what they see. Those rules, and why they held this event back from being declared a moment sooner, are what we look at next. There is a rulebook behind the word El Niño, and it exists to keep the term honest. Without firm rules, every warm month would invite a fresh announcement, and the public would learn to tune it out. So forecasters set a bar that is deliberately hard to clear by accident. Understanding that bar explains why the advisory arrived when it did, and not weeks earlier when the weekly readings first spiked. The core test is the one we have already met. Take the temperature of the sea surface in that central Pacific zone, measure how far it sits above or below the long-term average, and watch whether it crosses 0.5 degrees Celsius. But forecasters do not judge that on a single week, because the ocean is noisy and a warm week can come and go. Instead, they use a smoothed figure, an average built from 3 months at a time, slid forward month by month. That smoothing is what makes the measure trustworthy. It ignores the flickers and reports the trend. Then comes the patience rule, which is the part most people never hear about. To formally count as a full El Niño event, that 3-month average has to stay above the 0.5 degree line for 5 of these overlapping 3-month windows in a row. 5 in a row is most of a year. The rule is built that way on purpose, so that a brief warm nudge does not get crowned as a major event. It also means the official label often lags well behind what the ocean is plainly doing. The water can be warm, and the winds slack for weeks, while the count of qualifying windows slowly adds up. That is exactly the situation this event was in. The weekly readings had surged. The 3-month average, the patient 1, was still sitting just under the threshold in late spring. By the strict letter of the full definition, the event had not yet run long enough to be a confirmed full episode. So why issue an advisory at all? Because the advisory is not the same as the final tally. It is the forecasters saying that warm conditions are present right now and are expected to continue, and to meet the bar in the months ahead. It is a present tense signal, backed by a confident forecast, not a finished record. There is one more refinement worth knowing, because the agency has leaned on it more in recent years. The old measure simply asked how warm that one patch of Pacific was against its own history. The trouble is that the whole tropical ocean has been warming over the decades. If you only look at one patch, the steady background rise can make a modest El Niño look bigger than it really is, in terms of its effect on the winds. So forecasters now also track an adjusted version. They take the warmth of the key Pacific zone and subtract the warming of the wider tropical ocean around it. What is left is the part that is truly out of step with its surroundings, which is the part that actually drives the winds and the rain. That adjustment matters for this event in a quiet but important way. By the raw measure, the central Pacific looks strongly warm. By the adjusted measure, which strips out the global rise, the signal is real but more modest. both can be true at once. The water is genuinely hot, partly because El Niño is forming, and partly because the whole ocean is warmer than it used to be. Keeping those two contributions separate is how forecasters avoid overstating the strength of the pattern itself, and it is a habit this report will borrow when we judge how powerful this event is likely to become. So the rules did their job. They held the formal label back until the evidence was solid, while the advisory gave the public an honest early heads up. The system is warm now, the winds have eased, the forecast points to the bar being cleared, and the careful adjusted measure keeps everyone from getting carried away. That is a healthy way to announce a pattern that will shape the year. Knowing the rules also lets us see this event in its proper place, in the longer rhythm of the Pacific. It did not appear out of nowhere. It grew out of the state that came before it, and the recent history of this ocean has its own quiet story. That handoff, from what the Pacific was doing before to what it is doing now, is where we go next. This El Niño did not begin on a blank slate. The Pacific is always in one of its three moods, and the warm phase had to grow out of whatever came before. To see this event clearly, it helps to look back at the state it replaced, because the handoff tells you something about how quickly the ocean turned. In the stretch before this, the Pacific had been sitting in its calm middle, the neutral state, neither warm nor cool in any committed way. Before that, it had passed through a short spell on the cool side, a brief La Niña that did not last long or run deep. La Niña is the mirror image of what we are watching now. In that phase, the trade winds blow harder than usual, the warm water packs even more tightly against Asia, and the eastern Pacific runs cooler than normal. It tilts the world's weather the opposite way from El Niño in many places. That cool phase faded, and the ocean drifted back into its calm middle. Neutral sounds like the easy state, but it is the hardest one to forecast through. When the Pacific is strongly warm or strongly cool, it presses firmly on the atmosphere, and that firm press makes the coming seasons easier to read. In the calm middle, the ocean is not pushing hard in either direction, so the weather has more freedom to wander. Forecasters often describe neutral stretches as the foggy season for seasonal prediction. The signal is weak, so the confidence is low. That is the quiet from which this El Niño emerged. The turn, when it came, was fairly brisk. Through the early part of the year, the warm signal built steadily, and then over a span of weeks, the weekly ocean readings jumped well past the threshold. An ocean can take its time tipping over, or it can move with surprising speed once the deep warm water and the slackening winds start working together. This one moved at a good clip in late spring. That pace is part of why the forecast confidence climbed so fast, from a cautious maybe to a near certainty for the season ahead, in a fairly short window. It is worth saying plainly that not every warm nudge becomes a real El Niño. The Pacific has a habit of teasing. There have been years when the ocean warmed, the forecasters raised their odds, and then the pattern stalled and slid back to neutral without ever locking in. The deciding factor is almost always the atmosphere. If the winds refuse to ease, the warm water drains back west and the event dies on the vine. What separates this year from those false starts is that the air and the sea coupled together. The winds gave way, the pressure pattern shifted, the rainfall began to move, and the loop closed. That coupling is the difference between a flirtation and a committed pattern. There is also a longer rhythm worth holding in mind. The swing between warm and cool runs every 2 to 7 years, with no fixed beat. Over a long record, the warm and cool phases roughly trade off, though never on schedule and never with equal strength. Some warm phases are gentle and barely noticed. A few have been among the strongest climate events of their decades. Where this one will land on that range is still being worked out, but its early speed and the supporting forecasts have the major centres leaning toward at least a moderate event, with a real chance of something stronger. Stepping back, the handoff looks like this. A brief cool phase, then a foggy neutral stretch that was hard to forecast through, then a fairly quick warming as spring advanced, and finally the coupling of ocean and air that turned a warm spell into a confirmed pattern. Each stage flowed into the next without drama. The Pacific simply did what it has done for as long as there have been records, and longer. It leaned, it tipped, and it settled into its warm phase. What the ocean does next is the question everyone actually wants answered. The advisory confirms the present, but planning depends on the future. How strong will this El Niño get, and when will it peak? Forecasters have a clear expectation here, along with honest limits on how far ahead they can see. That forecast and the odds attached to it are what we turn to now. Now to the question that drives every plan built around this event. How strong will it get, and when? Forecasters do not answer that with a single number. They answer it with a direction and a set of odds, and both point the same way. This El Niño is expected to keep strengthening through the rest of the year and into the winter, reaching its peak somewhere in the heart of the cold season, before it begins to fade the following spring. That timing is the normal life story of an El Niño, and this one is following the script. The warm phase tends to take shape over the middle of the year, gather strength through the fall, and reach its most powerful point between late autumn and the depth of winter in the northern half of the world. Then it eases off through the following spring. So the months ahead are the building season. The turn of the year is when the pattern should be at full force, and the strongest effects on weather usually arrive with that winter peak rather than now. On strength, the forecasts lean toward at least a moderate event, with a genuine chance of a strong one. The most striking single number comes from the agency's own outlook. Forecasters put the odds at close to 2 in 3 that the Central Pacific will warm past 2 degrees Celsius above its average at the peak. Crossing that mark is the line that earns the label very strong, which is the top tier of these events. 2 in 3 is not a certainty. It is a clear lean, the kind of odds that tell planners to prepare for a substantial event while leaving room for it to land a notch lower. The agreement among independent forecasters is part of why the confidence is high. One research centre placed the chance of El Niño through the early summer at roughly 98 in 100, with the odds holding nearly that high straight through into the following winter. A separate international body put the likelihood through the summer at about 80 in 100, rising to 90 or better through late autumn. The exact figures differ, as they always do, but the shape of the message is identical across every major group. El Niño is here, it is expected to last, and it is expected to grow. It helps to separate strength from impact, because they are not the same thing. A strong reading in the ocean does not translate into strong weather everywhere on Earth. It raises the odds of certain outcomes in certain regions, and leaves much of the world only lightly touched. A very strong event tilts those odds harder, and reaches more places, but even then the effects are uneven. Some regions feel an El Niño winter sharply, others barely notice one. We will map who stands where in the chapters ahead. For now, the headline is simply that the dial is pointed toward the higher end. There is also a second-year effect worth flagging early, because it surprises people. The strongest push on global temperatures from an El Niño often shows up not in the year it forms, but in the year after. The ocean releases its stored heat into the atmosphere gradually, and the warmest global average tends to land in the calendar year following the peak. So even though this event is forming now, its largest mark on worldwide temperature records may not appear until well into next year. That lag will matter a great deal when we get to the heart of this report. Put the pieces together and the forecast reads cleanly. A warm phase that is here now, building through the fall, peaking around the turn of the year, with strong agreement across forecasters and a real chance of reaching the top tier of strength. The impacts on weather should be most pronounced around that winter peak. The mark on global temperature may run a year behind. That is a confident, well-supported outlook by the standards of this science, and yet confidence is not the same as certainty, and the honest forecaster says so out loud. There is a particular reason these spring and early summer forecasts carry a little extra doubt, a known weak spot in the science that has tripped up predictions before. Naming that weak spot and saying plainly what the forecast cannot promise is the fair next step before we follow this El Niño out into the world. Every honest forecast comes with its limits, and this one has a specific weak spot that deserves a plain name. Forecasters call it the spring barrier. It is the time of year when predictions of this specific pattern are least reliable, and it falls right around the season when this El Niño is being called. That timing is the main reason to hold the outlook with a steady hand rather than a tight grip. Here is the trouble in simple terms. Early in the year, the Pacific is often in transition, and the ocean signal that forecasters lean on is at its weakest and most changeable. A pattern trying to form in spring has not yet locked in, so small wobbles can still knock it off course. Forecasts launched through that window have a weaker track record than forecasts made later in the year, once the pattern has committed. It is not that the science fails, It is that the ocean itself is hardest to read at exactly that moment, and no amount of computing power fully fixes a signal that is genuinely faint. The forecasters issuing this outlook said as much themselves. Alongside the high odds, they noted that the predictions were being made near the end of that low-skill window, and that some uncertainty remained even though the probabilities looked impressive. That is the right way to speak. The headline numbers are strong, 90% and better in places, but those numbers were generated at the time of year when such numbers have historically deserved a touch more humility. Both things are true at once. The signal is strong, and the season argues for caution. What does that caution actually change? Less than you might think about whether El Niño is happening, and more about exactly how strong and how long. The present conditions are observed, not predicted. The ocean is warm right now, the winds have eased right now, and the coupling is real right now. None of that depends on a forecast. What the barrier touches is the reach into the future. The peak strength could come in a little softer than the top tier, or it could meet it. The fade next spring could run early or late. Those are the edges where the spring barrier blurs the picture. This is also a good moment to repeat a caution from earlier, because it guards against the most common overreaction. Even a confirmed strong El Niño does not hand any single place a guaranteed flood or a guaranteed drought. It shifts the odds across whole regions over whole seasons. A dry forecast for a region means dry is more likely than usual, not that rain is cancelled. A wet forecast means the reverse. People who treat a seasonal tilt as a firm promise end up either falsely alarmed or wrongly reassured. The useful mindset is the one forecasters use themselves. Watch the odds, prepare for the likelier outcome, and stay ready to be wrong at the margins. There is a phrase forecasters often repeat that captures the deepest uncertainty of all. Every El Niño is unique. No two events lay their warmth in quite the same place, peak at quite the same time, or interact with the rest of the climate in quite the same way. Two events with similar ocean temperatures can produce noticeably different weather around the world, depending on where exactly the warmth sits, and what other patterns happen to be active that year. History rhymes here, but it does not repeat. Past events are a guide, never a guarantee. So the fair summary is this. The presence of El Niño is as close to certain as this science gets, because it is being observed and not merely predicted. The forecast of strengthening through winter is strong and widely shared, but it was made during the season that earns a little extra doubt, so the exact peak and timing carry real uncertainty. And the translation from ocean strength into local weather is always a matter of shifted odds, never of promises. Hold all three of those together, and you are hearing this event the way the experts hear it. With the limits named honestly, we can follow the warmth outward with clear eyes. The next question is the big one. How does a change in one band of ocean, however large, end up touching weather on continents thousands of miles away? That reach is the most remarkable thing about this pattern, and it is where we turn now. Here is the part that can seem almost unbelievable at first. A change in the temperature of one band of ocean, sitting on the equator far from any major landmass, can shift the weather on continents thousands of miles away. A dry season in southern Africa, a flood on the coast of Peru, a mild winter in Canada, all can trace a thread back to that same warm strip of Pacific. The reach is real, it is well documented, and it works through a chain that is easier to follow than it sounds. Start with the simplest link, which lives in the tropics. We have already seen that El Niño moves the zone of heavy rainfall eastward across the Pacific following the warm water. That shift alone rearranges weather across the whole tropical belt. Regions that normally sit under the rising rainy air can be left under sinking drying air instead, and dry out. Regions usually parked under dry, sinking air can find the rainfall has drifted over them. Within the tropics, you can explain most of El Niño's effects just by tracking where the rain decided to go. The longer reach, into the middle latitudes where most people live, works through the rivers of fast wind high in the atmosphere. These are the jet streams, narrow bands of strong wind that snake around the globe miles above the surface and steer the storms below them. The jet streams are not fixed. They bend and shift in response to where heat is being released into the atmosphere. When El Niño dumps a great deal of heat and rising air into the central Pacific, that released energy nudges the nearby jet stream into a new path. Move the jet, and you move the storms it carries. For North America, that nudge has a familiar signature. During an El Niño winter, the jet stream over the northern Pacific tends to push southward and strengthen, dragging the storm track across the southern tier of the United States. The result is often a wetter pattern across the south and milder, drier conditions across the north. The northern Rockies and the inland valleys of the Ohio and Tennessee regions tend to run drier than usual, while the far north often sees a warmer winter than normal. None of these are guarantees. They are the tilts that show up again and again when you average many El Niño winters together. The honest complication is that the same released heat ripples outward in many directions at once, and the effects pile up differently in each region. A shift in the Pacific jet can knock onto patterns over North America, which can knock onto patterns over the Atlantic and Europe, each link a little weaker and a little less certain than the one before. This is why El Niño's fingerprints are sharp and reliable in the tropics and the nearby Pacific, and grow fainter and harder to pin down the farther you travel from the source. The signal does not vanish at a distance, it just gets harder to separate from everything else the atmosphere is doing. There is one more reason this pattern carries such weight, and it is a hopeful one. Because the ocean changes slowly and the warm phase tends to last for months, forecasters can often see an El Niño coming and read its likely effects seasons in advance. Most weather can only be forecast a week or so ahead. The seasonal tilts that El Niño brings can be anticipated far earlier, which gives farmers, water managers, and emergency planners a rare head start. The reach of this pattern is what makes it dangerous in places, but the predictability of that reach is what makes it manageable. So the chain runs like this. Warm water moves the tropical rain, the released heat bends the jet streams, and the shifted jets carry the storms to new places, with the effect strongest near the Pacific and softer far away. That is how one ocean reaches a whole planet. To make it concrete, we need to know exactly where the warm water is sitting in this particular event, because the precise location of the warmth shapes which version of these effects the world will get. That map is where we go next. The exact location of the warmth is not a detail. It is the thing that decides which flavour of El Niño the world experiences, so it is worth getting the geography right. Forecasters divide the equatorial Pacific into a set of monitoring zones, numbered from the South American coast westward toward the centre of the ocean, and they watch the temperature in each one separately. Where the warmth piles up among those zones changes the whole character of the event. The zone that matters most for the formal definition sits in the central Pacific, well out in the open ocean, far from any coast. This is the patch we have been describing all along, the one whose temperature, smoothed over 3 months, decides whether the warm phase is officially on. In this event, that central zone is clearly warm and getting warmer, which is the core of the advisory. But the central location of the main warmth also tells forecasters something about the kind of El Niño taking shape. A warm pool centered out in the middle of the ocean tends to behave a little differently from one pressed hard against South America. Picture the warmth as a tongue of warmer than normal water laid along the equator. In a classic Eastern-style event, that tongue reaches all the way to the South American coast, and the strongest warmth sits there, off Peru and Ecuador, just as the old fishermen first noticed. In a central-style event, the strongest warmth sits farther west, out in the middle of the Pacific, and the coast stays comparatively less affected. The two styles steer rainfall and storms in subtly different ways, even when the headline ocean temperature is similar. This is one reason two El Niños with the same strength on paper can deliver different weather. The deeper ocean is part of this map as well, not just the surface. Beneath the warm tongue lies a reservoir of warm water that has been sliding eastward along the equator, sitting a few hundred feet down. That subsurface warmth is the fuel tank. As long as it keeps feeding the surface, the warm phase can sustain and strengthen. When that deep supply runs low, the surface warmth begins to fade and the event winds down. Forecasters watch the subsurface as closely as the surface precisely, because it tells them what the coming months hold. In this event, the deep warm pool was well stocked as the pattern formed, which supports the forecast of further strengthening. Why does the precise placement matter so much for the rest of us? Because the zone of rising air and heavy rain anchors itself over the warmest water. Slide the warmest water east or west, and the rain and the heat feeding the jet streams slides with it. An event with its warmth centered in the middle of the ocean nudges the jet streams from a different launching point than one with its warmth jammed against the coast. that difference flows downstream into which regions feel the sharpest effects. The map of the ocean becomes, a few steps later, the map of the weather. It is also worth remembering that the warmth in this event is not all the doing of El Niño. The entire tropical Pacific has been running warmer than its long-term average for years, lifted by the broader warming of the planet. So part of what the instruments see in every monitoring zone is the warm phase, and part is that raised background. Forecasters keep these separate by using the adjusted measure we discussed earlier, which strips out the wider ocean warming to reveal the part that is truly El Niño. On the raw map, the whole Pacific looks hot. On the adjusted map, the genuine El Niño signal stands out from a warm but separate backdrop. With the geography in hand, the most important consequence becomes easier to follow. The warmth has moved, the rising air and the rain have moved with it, and that shift in rainfall is the first and clearest way the world feels an El Niño. Tracing exactly how the rain rearranges itself across the tropical Pacific and which way it leans in this event is what we take up next. Follow the rain, and you follow the heart of El Niño. Of everything this pattern does, the shift in rainfall is the first to appear and the easiest to see, because rain goes where the warm, rising air goes, and El Niño moves that rising air. So the simplest way to track the pattern across the tropics is to watch where the heavy rains pack up and where they move to. Begin with the normal arrangement, since the change only makes sense against it. In a calm year, the warmest tropical water sits in the far western Pacific, around Indonesia and the islands of the maritime continent. Warm water there feeds warm, moist, rising air, and that rising air builds the towering storms that drench the western Pacific year after year. Meanwhile, the eastern Pacific, cooler and capped by sinking air, stays comparatively dry. The rain has a home in the west, and it largely stays there. El Niño breaks up that home. As the warmest water slides east toward the center of the ocean, the zone of rising air and heavy rain follows it out over open water. The western Pacific, suddenly sitting under air that is no longer rising as strongly, can dry out. The central Pacific, normally dry, finds itself under storms it does not usually host. The total amount of tropical rain does not change much. Its address does. And that change of address is what dries out one set of countries while soaking another. The drying side of this seesaw lands first and hardest on the lands of the western Pacific and the nearby tropics. As the rain pulls away to the east, the islands of Indonesia, much of the surrounding region, and lands that depend on that western rainfall tend to swing toward drought. This is not a faint effect at the source. It is one of the most reliable signatures of an El Niño anywhere on Earth, because it sits right at the spot where the rising air has moved away. When forecasters look for early confirmation that a warm phase has truly taken hold, a drying western Pacific is one of the first things they check, and in this event it was part of the evidence behind the advisory. The wetting side shows up out over the central and eastern Pacific, and along parts of the South American coast where the warm water now reaches. Stretches of ocean that normally quiet can light up with storms. Coastal regions of Peru and Ecuador, the same coast where the warming was first named long ago, can see heavier rain than usual when the warmth pushes far enough east. The rain that left the western Pacific did not disappear. It set up shop in a new place, and the new place is not always built to handle it. It is worth holding on to how steady and physical this is, because it strips the mystery out of El Niño. There is nothing mystical about a pattern that can reach across the globe. It is rising air carrying moisture upward to form rain, and that rising air anchoring itself over the warmest water it can find. Move the warm water, and the rain moves with it. Everything else El Niño does to the wider world, all the bent jet streams and shifted storm tracks, grows from this first simple fact about where the tropical rain decides to fall. This rainfall seesaw is also the engine room for the regional effects we are about to tour. The drought in one belt of the world and the flooding in another are not separate stories. They are two ends of the same shift, the dry end where the rain left and the wet end where it arrived. Keeping that single picture in mind will make the regional chapters click into place, because each one is really just a local view of this one global rearrangement of rain. Before we walk that map region by region, it helps to look back at the last time this pattern reached full, ferocious strength, so we have a real yardstick to measure this event against. A decade ago, the Pacific produced one of the most powerful warm phases ever recorded, and the world felt it from coast to coast. That event, what it did, and how this one compares is where we turn next. To judge how big this event might become, it helps to stand it next to the last truly powerful one. About a decade ago, the Pacific produced one of the strongest warm phases in the modern record, a so-called Super El Niño, and the world had a clear look at what the top tier of this pattern can do. Holding that event up as a yardstick keeps the present forecast honest, in both directions. That earlier event crossed the very threshold this one is now given a real chance of reaching. The central Pacific warmed well past 2 degrees Celsius above its average at the peak, deep into the very strong category. The warmth was immense, the coupling between ocean and air was complete, and the pattern held its grip through a full northern winter before fading the following spring. It was about as large as these events get, and because it was so large, its effects were unusually widespread and easy to attribute. The consequences read like a tour of the seesaw we just described, written in extremes. Parts of the Western Pacific and Southeast Asia fell into severe drought as the rain pulled east, with serious stress on crops and water supplies, and a bad season of fires in the tangled dry forests of the region. Eastern Africa saw destructive flooding in places. Parts of the Americas saw their own floods and storms where the shifted jet stream steered the weather. And across the globe, the released ocean heat helped push worldwide temperatures to a record at the time, with the warmest year landing in the calendar year that followed the peak, exactly the lagged effect we flagged earlier. That last point is the most useful piece of the comparison for this report. The biggest mark a strong El Niño leaves on global temperature tends to arrive the year after it forms, as the ocean slowly hands its stored heat to the atmosphere. A decade ago, that handoff helped set a global heat record. This event is forming on a planet that is already warmer than it was back then, which is the thread we will pull hard in the chapters ahead. The yardstick is not only how strong the Pacific got, but what floor it was building on top of. Now the honest caution, because comparisons can mislead as easily as they inform. This event is not guaranteed to match that one. The forecasts give it a real chance of reaching the very strong tier, close to 2 in 3 by one measure, but a real chance is not the same as a sure thing, and the spring barrier we discussed leaves room for it to land a step lower. It could become a powerful event that rivals the one from a decade ago. It could also settle into the moderate range and touch the world more gently. Both remain on the table as the pattern builds. There is also the matter of personality, the reminder that every El Niño is unique. Even if this event matches that earlier one in raw ocean temperature, it need not match it in effect. The warmth could sit in a slightly different place, peak at a slightly different time, or run into different companion patterns elsewhere in the climate. Any of those could steer the weather down a different path than the one the world walked a decade ago. The earlier event is a guide to what is possible, not a script for what is coming. What the comparison gives us in the end is a sense of scale, and a sense of proportion at the same time. Scale, because it shows that a warm phase reaching the top tier can move weather and temperature records across the entire planet, and this one has a genuine shot at that tier. Proportion, because it reminds us that the outcome is still uncertain, that a lighter event is fully possible, and that even a strong one rolls the dice rather than dictating the result. With that yardstick in hand, we're ready to walk the map. Now we walk the map, and we start on the dry side because that is where an El Niño announces itself most reliably. As the heavy tropical rain pulls eastward away from the Western Pacific, a broad belt of the world tilts toward drought. These are the lands that normally sit under the rising rainy air that El Niño shoves out to sea. When the rain leaves, the dry air moves in behind it, and the season runs short of water. The clearest example sits right at the source. Indonesia and the islands of the surrounding region lose their rain first and most reliably, because they lie exactly where the rising air has moved away from. A drier season there raises the risk of water shortages and of fires in the dry forests and peatlands, the kind of fires that can smother whole regions in haze. This drying is so dependable that forecasters treat it almost as a confirmation light for the pattern itself. In this event, the early signs of a drier Western Pacific were part of the evidence that El Niño had truly taken hold. Australia tends to feel it too, especially across the east and the north. El Niño years there often run hotter and drier, with a higher risk of heat, water stress, and bushfire as the wet season underperforms. The Philippines sits squarely in this belt as well, and an El Niño commonly brings drier conditions and a real chance of drought that can press on water supplies and on farming through the dry months. For anyone living across these islands, this is not a distant story. It is the local forecast leaning toward less rain than usual in the seasons ahead. The belt reaches well beyond the Pacific Rim. Parts of southern Africa often turn drier during an El Niño, which matters greatly in a region where so many people farm on the rain that falls in a single growing season. India and the wider stretch of South Asia frequently see their seasonal rains run below average, a point large enough that we will give the monsoon its own chapter shortly. Across all these places, the common thread is the same. The rain that used to arrive on schedule arrives lighter, or later, or not at all. It is important to say what this does and does not mean, because drought is a word that frightens people. A tilt toward drought does not mean the rain is cancelled. It means the odds have shifted toward a drier than normal season across a wide area over several months. Some places in the belt will still get decent rain, others will fall well short. What forecasters can say with confidence is that the risk is raised, not that any one field or reservoir is doomed. That distinction is the difference between useful preparation and needless fear. The good news in the dry story is the head start. Because El Niño can be seen forming seasons ahead, the regions in this belt are not caught blind. Water managers can plan reservoir releases more carefully. Farmers can weigh hardier crops or adjusted planting dates. Fire services can stage resources before the dangerous months arrive. Governments and aid agencies can pre-position help in the places history flags as most exposed. None of this erases a drought, but it softens the blow, and that early warning is one of the few genuine gifts this pattern offers. The standard guidance for people in the drought belt is calm and familiar. Follow the seasonal outlooks from your National Weather Service rather than rumour. Treat water as the precious thing it becomes in a dry year, and conserve early rather than late. If you farm, talk with local agricultural advisors about choices suited to a drier season. In fire-prone areas, clear what you can around your home and know your local warnings. These are ordinary steps, the same ones a careful season always calls for, taken a little sooner because the odds have shifted. So the dry side of the seesaw runs in a long arc, from Indonesia and the Philippines through Australia and across to southern Africa and South Asia, all of it tilting toward less rain as the tropical storms drift east. Hold that arc in mind because it is only one half of the picture. The same shift that empties the rain from one side of the world delivers it, sometimes violently, to the other. That wet side, and the flooding that can come with it, is where we turn next. The rain that leaves the dry belt has to land somewhere, and that somewhere is the wet side of the seesaw. As the storms drift east across the Pacific, a different set of regions tilts toward heavier rain and a raised risk of flooding. These are the places that sit under the rising air in its new position, or in the path of the storm track once the jet stream bends. For them, the season ahead leans wetter than usual, sometimes sharply so. The coast where El Niño was first named feels this most directly. Along Peru and Ecuador, the warm water pressing against South America can bring heavy, sometimes destructive rain to a coast that is normally dry. In a strong event, rivers swell, hillsides give way, and lowland towns can flood. This is the eastern edge of the warm tongue made personal, the same warming the fishermen noticed centuries ago, now expressed as too much rain rather than too little fish. How far this reaches depends on how far east the warmth pushes, which is one of the things still coming into focus in this event. Southeastern South America often joins the wet side as well. Parts of Argentina, Uruguay, southern Brazil and Paraguay tend to see above average rain during an El Niño, as the shifted patterns steer more moisture their way. For a region that grows a great deal of the world's grain and soy, a wetter season can be a mixed blessing, helpful for some crops and harmful for others, and capable of flooding farmland if the rain comes too hard and too fast. The same water that relieves one field can drown the next. East Africa is another classic wet zone in an El Niño year. The short rains across parts of the region often run heavier than usual, which can be a relief after dry spells but can also bring flooding, displacement, and the disease outbreaks that follow standing water. This is one of the sharper double edges of the pattern. The very same event that dries out southern Africa can soak the eastern side of the continent. Two opposite outcomes on one landmass, both flowing from the same shift in the Pacific. Across the wet belt, the hazards rhyme even where the geography differs. Heavy rain over short periods is the common danger, and it brings flash floods, river floods, landslides on steep ground, and the slower miseries that come after the water recedes. Cities with crowded low-lying districts and stretched drainage are especially exposed because the rain does not need to be historic to overwhelm a system that was already near its limit. As with the dry side, the tilt is toward more rain and higher risk, not a guarantee of catastrophe, but the raised odds are reason enough to prepare. The safety guidance for the wet belt is standard and worth stating plainly. Listen to your National Weather Service and heed flood watches and warnings when they come. Know whether you live or work on low ground or near a river or a slope that could fail. Never drive or walk through floodwater, since it is deeper, faster and stronger than it looks, and a surprising amount of harm in floods comes from people entering water they underestimated. Keep important documents and a few days of supplies somewhere you can grab them quickly. These steps are ordinary, and they save lives in exactly the kind of season the odds now favour. The early warning gift applies here too. Because the wet tilt can be anticipated seasons ahead, exposed regions have time to clear drains, check defences, ready shelters, and remind people of evacuation routes before the heavy months arrive. A flood that is expected is far less deadly than one that is not, even when the rain itself is the same. The reach of El Niño is what raises the danger across these regions, and the predictability of that reach is what gives them a fighting chance to meet it well. So the wet and dry belts are two halves of one rearrangement. The rain pulled from the western Pacific and delivered to the eastern Pacific coast, to southeastern South America, and to East Africa, among others. One region of that wet and dry map carries stakes large enough to deserve its own chapter, because it feeds well over 1 billion people and turns on a single season of rain. That is the South Asian monsoon, and it is where we go next. Some regional effects of this event matter more than others, simply because of how many people depend on them, and few rivals the South Asian monsoon. Each year, a vast seasonal rain sweeps across India and its neighbours, delivering most of the water the region will see in 12 months in the space of a few. Farms, reservoirs, rivers, and the food supply for well over 1 billion people all hinge on whether that rain arrives and how much of it falls. El Niño has a long history of nudging that rain downward, which is why this chapter stands on its own. The link is real, but it is gentle, and it must be stated carefully. El Niño years tend to tilt the monsoon toward below-average rainfall across much of South Asia. The tilt is a tendency, not a rule. There have been El Niño years with weak monsoons, and there have been El Niño years where the rain held up fine, because other patterns in the region can push the other way and cancel the effect. So the honest forecast is a raised risk of a drier monsoon, not a promise of one. In this event, the regional outlook leans toward a below-average season, in line with that long tendency. To feel why even a modest shortfall matters, picture how the water is used. A great deal of South Asian farming is fed directly by the monsoon rain rather than by irrigation, so the crops planted for the season depend on the rain coming on time and in enough quantity. The same rain refills the reservoirs that supply cities and power and drinking water through the long dry months that follow. When the monsoon underperforms, the shortfall does not stay in the fields. It reaches into water supplies, into electricity where it depends on dams, and eventually into the price and availability of food. The crop most often watched is rice, a thirsty staple planted with the arrival of the rains. But the worry runs across many crops and the livelihoods tied to them. A weak monsoon can lower yields, strain the farmers who planted on the expectation of the normal rain, and ripple outward into rural incomes and in time into markets far beyond the region. Because South Asia is such a large producer and consumer of certain staples, a poor season there can be felt in global food prices, a thread we will pick up when we reach the wider economic effects. There is a reassuring side, and it is the same one that runs through this whole report. The monsoon is among the most studied and most forecast seasonal events on Earth, and an El Niño that is visible months ahead gives the region a long runway to prepare. National forecasters issue detailed monsoon outlooks. Governments can manage water stores more carefully, adjust support for farmers, and ready food reserves against a weaker season. Farmers, warned early, can lean toward hardier crops or adjust their planting. None of this manufactures rain, but it blunts the harm of a shortfall, and the region has grown steadily better at it. The plain guidance for those who depend on the monsoon is to trust the official seasonal outlooks and the agricultural advisories built on them, rather than rumour or a single bad forecast headline. A below-average outlook is a reason to plan for less water, not a reason to panic. Many seasons that begin under an El Niño shadow still deliver enough rain to get through, and the value of the warning lies in careful preparation, not in fear of a season that has not yet failed. So the monsoon sits at the heart of the dry side of this event, a single season of rain that turns the year for an enormous share of humanity, leaning toward the lighter end under El Niño's influence. It is the clearest case of how a shift in one ocean can reach into kitchens and markets a world away. From the monsoon we move to a region where the stakes are sharpest of all, where the margin between a normal season and a hard one is thinnest, the Greater Horn of Africa. Some places have less room to absorb a bad season than others, and the Greater Horn of Africa is one of them. Spanning the eastern edge of the continent, the region has lived through repeated dry years and stretches of food insecurity, so the margin between getting by and falling short can be painfully thin. That is why the seasonal outlook here, under this El Niño, deserves its own careful and calm look. The stakes are measured in harvests and in the basic security of millions of people. The outlook for the region is mixed, which is exactly why it needs care rather than a single headline. Regional climate forums, the bodies that pull together forecasts for Eastern Africa, have flagged a likelihood of below normal rainfall across much of the northern part of the Greater Horn during the main rainy season that runs through the middle of the year. A drier main season in a region already prone to drought is a serious matter because it presses on crops and grazing land at the same time, and the effects stack from one dry season to the next. At the same time, El Niño's classic signature for parts of East Africa can run the other way later in the year, toward heavier than normal short rains. So the region can face a difficult sequence, a drier main season followed by a chance of heavy short rains, with drought stress and flood risk arriving in turn rather than sparing the region either one. That double exposure, dry then wet, is one of the hardest patterns to manage, and it is a real possibility in the months ahead for parts of the Horn. The human stakes are what set this region apart. Where so many people depend on rain-fed farming and on herds that need pasture and water, a poor rainy season translates quickly into lost crops, weakened livestock, and rising hunger. Floods, when they come, bring their own harm, displacing families and spreading the diseases that follow standing water. These are not abstract risks in a region that has faced them before. They are the reason humanitarian agencies watch the El Niño forecast as closely as any government does. Here the early warning matters more than anywhere. Because the pattern was visible forming seasons ahead, aid agencies and governments have a window to act before the worst arrives. International weather bodies brief humanitarian groups directly so that food, water and medical supplies can be moved toward the region's history flags as most exposed, ahead of need rather than after it. Pre-positioning help is far cheaper and far more effective than responding once a crisis is underway, and the months of warning an El Niño provides are precisely what make that possible. It is worth holding the tone steady here, because regions like this are too often described only through their worst seasons. A raised risk of below normal rain is not a forecast of famine. It is a signal to prepare, and the preparation genuinely works. Early action has blunted the impact of past events, and the same machinery is turning now. The honest message is serious but not hopeless. The region faces a harder than average season under this El Niño, and the systems built to help it have a real head start this time. For people living in the region, the guidance flows through trusted local and national channels, the meteorological services and the agricultural and disaster agencies that translate the broad outlook into specific advice. Following those official sources, conserving water early, and heeding any warnings about flooding in the wetter season are the steady, ordinary steps that carry a community through a hard year. The same calm preparation that serves the rest of the world serves the Horn, with higher stakes attached. The Greater Horn of Africa shows the human face of this pattern most plainly, a place where a shift in the distant Pacific can press directly on whether families have enough to eat. From these effects on land, the event reaches the sea and the sky in another way entirely, reshaping where the great storms of the season form and where they do not. That trade in storms, the quiet Atlantic and the stirred Pacific, is where we turn next. El Niño does not only move rain across the land, it also reshapes where the great storms of the season form at sea, and the result is a kind of trade. As the pattern takes hold, it tends to quiet the storms in one ocean basin while stirring them up in another. The reason lies in the high-level winds, and following it makes the whole effect simple to understand. Start with the Atlantic, where the news is good. During an El Niño, the United States Science Agency expects a below-normal Atlantic hurricane season, and it has forecast exactly that this year. The mechanism is something called wind shear, which is just a change in wind speed or direction with height. Hurricanes need a tall, stable tower of rising air to organise and grow. When the high winds are blowing hard in a different direction from the surface winds, they tear at that tower and pull a forming storm apart before it can strengthen. El Niño tends to pump extra high-level wind across the Atlantic, raising the shear and making it harder for hurricanes to take shape. Fewer storms and weaker ones are the usual result. The Pacific gets the opposite deal. The same pattern that raises hurricane-wrecking wind shear over the Atlantic tends to lower it over parts of the central and eastern Pacific, while the warm ocean there supplies extra fuel. So while the Atlantic quiets, the central and eastern Pacific can grow more active, with a raised chance of storms, including ones that track near Hawaii or out across open water. The storms are not created or destroyed on balance so much as encouraged in one place and discouraged in another, which is why a trade is the right way to picture it. This trade is one of the more dependable effects of an El Niño, but it is still a tilt rather than a guarantee, and it carries an important caution. A below-normal Atlantic season does not mean no storms, and it does not mean no danger. It takes only one hurricane reaching a coast to make a quiet season deadly for the place it hits. Seasons with few storms overall have still produced devastating individual landfalls, so the right way to hear a below-normal forecast is as a lowered overall count, not as permission to relax. Anyone in a hurricane zone should prepare exactly as they would in any year. The Pacific side carries its own version of that caution in reverse. A more active central or eastern Pacific raises the odds that islands and coastlines in those regions will face a storm, so the same forecast that brings relief to the Atlantic is a reason for heightened readiness across the Pacific. The lesson cuts both ways. El Niño shifts the risk from one ocean to another, and the people on the receiving end of that shift need to know it is coming. There is a deeper point in this trade about how El Niño works. It rarely adds or removes weather from the world as a whole. More often it moves weather from one place to another. The rain leaves the western Pacific and lands in the east. The storms leave the Atlantic and stir in the Pacific. The total stays roughly in balance while the map of who is affected gets redrawn. Once you see that pattern, the long list of El Niño's effects stops looking like a grab bag and starts looking like a single rearrangement, viewed from many different windows. For people in storm country, the guidance is the same steady advice that holds every year, adjusted only in emphasis. In the Atlantic basin, treat a quiet forecast as no reason to drop your guard and keep your hurricane plan and supplies ready, because one storm is all it takes. In the Pacific, take the raised activity as a prompt to be especially prepared. Follow your National Hurricane Center, know your evacuation zone, and ready your kit before the season peaks. The forecast tells you where the odds have moved. Your preparation is what turns that knowledge into safety. The storm trade reaches across the sea surface, but El Niño's effect on the ocean runs deeper than the storms it steers. The warmth itself changes life in the water, from the coral reefs to the fish that coastal communities depend on. That quieter story beneath the waves is where we turn next. Beneath the storms, the warmth itself is doing something to the ocean, and this part of the story unfolds quietly. El Niño does not only rearrange the weather above the sea, it heats the sea, and the life within it feels that heat directly. The corals, the fish, and the communities that depend on them live the El Niño not as a forecast, but as a change in the water around them, and that change can be hard. The reefs feel it first and most visibly. Corals are living animals that host tiny algae inside them, and those algae give the coral both its colour and most of its food. When the water grows too warm for too long, the coral expels the algae and turns a stark, ghostly white, a state called bleaching. A bleached coral is not dead, but it is starving and under severe stress, and if the heat lasts long enough, large stretches of reef can die. El Niño, by spreading a blanket of unusually warm water across wide areas of ocean, is one of the great triggers of mass bleaching, and a strong event can stress reefs across whole oceans at once. This matters far beyond the beauty of a reef. Coral reefs are nurseries and shelter for a huge share of ocean life. So when reefs suffer, the fish that live among them suffer too, and the fishing communities that depend on those fish feel it in their catch and their income. A bleaching event triggered by a strong El Niño can echo through a coastal economy for years, because reefs recover slowly even in the best case. The warm water that looks like a number on a chart becomes, at the reef, a question of whether the fishery holds. The open ocean fisheries feel a different version of the same heat. We met this effect at the very start in the old story of the Peruvian fisherman. In a normal year, cold, nutrient-rich water rises along the South American coast and feeds an enormous population of small fish, which in turn feeds everything larger. El Niño shuts off much of that upwelling. The warm surface water caps the cold water below, the nutrients stop rising, the small fish scatter or die back, and one of the most productive fisheries on Earth can collapse for a season. This is the original El Niño effect, the one that gave the pattern its name, and it still bites today. There is a broader point here about heat in the sea that connects to the heart of this report. The ocean has been absorbing the great majority of the extra heat trapped by a warming planet, which means the water was already running warmer than it used to before this El Niño added its own pulse on top. So the marine heat in this event is not starting from a cool baseline. It is stacking onto an ocean that has been heating for decades, which raises the risk that bleaching and other heat stress reach further and last longer than they would have in the past. The reefs are facing the warm phase and the warming together. The honest measure of all this is uncertainty about the exact toll, paired with confidence about the direction. Whether this event triggers widespread bleaching depends on how warm the water gets, how long the heat lasts, and exactly where it settles, none of which is fully known yet. What is clear is that a strengthening El Niño raises the risk of marine heat stress, and that it does so on top of an already warm ocean. Scientists who monitor reefs and fisheries are watching closely, with the same early warning that helps the people on land. The life beneath the waves, then, is one more place where this single Pacific event reaches, from the corals to the small fish to the people who haul them in. And the thread that runs through this chapter, the warm phase landing on an ocean already heated by a warming world, is the exact thread that the whole report has been building toward. That overlap between a natural cycle and a long-term rise is the real implication behind this event, and it is where we turn now. This is the chapter the title was pointing to, and it is worth stating plainly and without drama. The most important thing about this El Niño is not the El Niño by itself, it is where it is landing. This warm phase is forming on a planet that has already been running at record warmth year after year, and that overlap is what gives an ordinary cycle an extraordinary edge this time. Keep the two things clearly separate because the whole point depends on not confusing them. El Niño is a natural cycle. It comes and goes every few years. It has done so for as long as there have been records and far longer, and it adds no lasting heat to the planet. It simply moves heat around and for a season or two lets the ocean hand some of its stored warmth to the atmosphere. The long-term warming is a different thing entirely, a steady rise in the background temperature of the whole Earth that does not swing back the way El Niño does. One is a wave, the other is the rising tide beneath it. What happens when a wave rides in on a rising tide is the heart of this story. On its own, an El Niño gives global temperatures a temporary bump, lifting the yearly average for a season before it settles back. In the past, that bump rode on a lower baseline, so even a strong event pushed the world to a record that, by today's standards, looks modest. Now the baseline itself is far higher. The same size bump added to a much higher starting point can carry global temperature to levels never measured before. The cycle has not grown stronger, the floor it stands on has risen. We have a recent yardstick for this, the strong event from a decade ago. Back then, the warm phase helped push the world to a global heat record, with the warmest year arriving the year after the peak, as the ocean slowly released its heat. Since then, the background has climbed further, and the planet has gone on setting new heat records even in years without an El Niño to help. So this event is forming on a baseline meaningfully warmer than the one that produced that earlier record. If it strengthens as forecast, the temporary bump it brings will be added to that higher floor. That is the implication, said simply. A strong El Niño arriving now raises the odds that the coming year or two will see new highs in global temperature, very possibly beyond anything yet recorded. And because the strongest temperature effect tends to lag by a year, the largest mark may land not in the year the event forms, but in the one that follows. The danger is not that El Niño has changed. The danger is that it is amplifying conditions that were already at the edge, the way a small push can matter most to someone already leaning over a line. The word terrifying, which the title borrowed, deserves an honest handling here, because this report does not trade in fear. The genuinely sobering part is not a single dramatic event. It is the quiet arithmetic of a temporary natural bump landing on a permanently raised floor, and what that arithmetic means for heat, for the ocean, and for all the regional effects we have walked through, each one now playing out against a hotter backdrop than before. Stated plainly, that is serious enough. It does not need inflating, and inflating it would only make it easier to dismiss. It is just as important to say what this does not mean, because overstatement helps no one. A record warm year is not the end of anything, and a single El Niño does not decide the long-term path of the climate. The warm phase will peak and then fade, and global temperatures will ease back from the bump even as the underlying baseline stays where it is. What this event offers is a preview, a temporary glimpse of where the steady warming is heading on its own over time. That is the real value in watching it closely, and the reason it is worth 2 hours of careful attention. The clearest place this overlap will show itself is in the temperature record of the coming year. The likely size and timing of that push on global temperatures and how to read it without alarm is where we turn next. If the implication of this event shows up anywhere first, it will show up in the global temperature record, so it is worth understanding how that number behaves. The figure that scientists track is the average surface temperature of the entire planet, ocean and land together, compared against a long-term baseline. It is a single number standing in for the whole Earth, and an El Niño has a well-known habit of nudging it upward for a time. The reason is the heat handoff we have met before. During the warm phase, the Pacific releases a large amount of stored heat from the ocean into the atmosphere. Since the global temperature number includes the air and the sea surface, that release shows up as a temporary rise in the worldwide average. When the event fades, the bump fades with it, and the number eases back toward the underlying trend. On its own, an El Niño does not move the long-term line. It rides above it for a season and then steps back down. The timing of that bump is the part that surprises people, and it is worth repeating because it shapes how the coming year will read. The largest push on global temperature usually arrives not in the year the event forms, but in the year after. The ocean releases its heat gradually, so the warmth builds through the event and crests after the peak. A decade ago, the warmest year on record at the time landed in the calendar year following that strong event's peak. If this event follows the same script, its biggest mark on the global average may not appear until well into next year. Put the bump and the baseline together and you get the outlook for the temperature record. The world has already been setting heat records on the strength of the long-term warming alone, even in recent years without an El Niño to help. Add a strengthening warm phase on top, and the odds rise that the coming year or two will reach new highs, quite possibly the warmest ever measured. This is not a certainty, since the size of the bump depends on how strong the event becomes, and the spring barrier still clouds that. But it is the clear lean, and it is why scientists are watching the global average so closely now. It is important to read such a record calmly and correctly, because a headline about the hottest year can be either underplayed or overblown. A new high would not mean the climate has lurched suddenly. It would mean the steady upward line and a temporary El Niño bump happen to meet at a peak, exactly as the science expects. Nor would the record stand as a permanent new normal. After the event fades, the global average would likely ease back from the peak, even though the underlying trend keeps rising over the longer run. A record year is a crest on a rising tide, not a cliff the world has fallen off. What the temperature spike really offers is information, and that is the useful way to hold it. By briefly lifting the world to where the long-term trend is heading anyway, a strong El Niño gives a preview of conditions that will become ordinary later if the warming continues. The heat, the marine stress, the strain on crops and water, all of it shows up a little early and a little concentrated during the warm phase. Watching how the world handles this temporary spike is, in a real sense, a rehearsal, and the lessons learned from it carry forward. For an individual, the global average is an abstract number, but the heat behind it is not. A warmer than usual stretch raises the risk of dangerous heat in many places, and the standard guidance is the same calm advice that any hot season calls for. Pay attention to heat warnings from your local service, drink water, find cool space during the hottest hours, and check on the elderly and the very young and anyone who works outdoors, since they bear the heat hardest. These ordinary steps matter more in a year when the odds tilt warmer, and they cost nothing to take early. So the temperature spike is the clearest near-term signal of this event's deeper meaning, a likely new high in the coming year or two, landing with a lag, riding a baseline that has never been higher. From this single global number, the effects fan out into the practical concerns of daily life, into the food on the table and the water in the tap and the prices at the market. That slower ripple is where we turn next. The effects we have traced finally reach the places people feel most directly: the food on the table, the water in the tap, and the prices at the market. This is the slow ripple of an El Niño, the part that arrives not as a storm or a headline, but as a gradual pressure over months, and it deserves a calm and clear accounting because it is easy to either ignore or exaggerate. Start with food, since that is where the chain is most direct. We have already seen the pattern tilt toward drought across one belt of farming regions and toward heavy rain across another. Both can lower harvests. Drought starves crops of water, while too much rain at the wrong time can flood fields, delay planting, or rot what is in the ground. When several important growing regions have a hard season at once, the total supply of a crop can dip, and a dip in supply tends to nudge prices upward. That is the mechanism by which a warm patch of distant ocean can, months later, show up in the cost of a bag of rice or a loaf of bread. Certain crops and regions sit closer to this risk than others. The rice of South Asia, exposed to a weaker monsoon, is one. The grain and soy of southern South America, exposed to flooding, is another. Coffee, cocoa, sugar, and palm oil all grow in regions that El Niño can touch, which is why a strong event sometimes registers in the prices of everyday goods, far from where the weather actually changed. The world's food is grown in specific places, and when El Niño leans on several of those places at once, the effect can travel along the supply chains that connect them to everyone else. Water is the quieter half of the story, and it follows the same logic. In the drought belt, a dry season draws down the reservoirs that supply cities, farms, and power, and a deep enough drawdown can mean water restrictions, higher costs, or strain on electricity where it depends on dams. In the flood belt, the problem is reversed, with too much water at once overwhelming systems and fouling supplies. Either way, the season's rainfall, tilted by the distant Pacific, works its way into the most basic resource a community has, and the effects can outlast the event itself by months. It is essential to keep this in proportion, because food and price stories invite panic, and panic helps no one. An El Niño raises the risk of supply pressure and higher prices in certain goods. It does not by itself cause a general shortage or a runaway spike, and the modern food system is large, global, and able to shift supply between regions to cushion a bad season in any one place. Most El Niño events pass without a food crisis in well-supplied parts of the world, registering as a modest bump in a few prices rather than a shock. The serious risk concentrates in places that were already stretched, where even a small shortfall lands hard. That uneven burden is the honest heart of the economic story. The same event that means a slightly pricier cup of coffee in a wealthy country can mean a genuine threat to food security in a poorer region that depends on a single rain-fed harvest. The pattern does not distribute its cost evenly, and the places with the least cushion tend to feel the most. This is why the early warning and the pre-positioning of aid that we discussed matter so much. They are aimed precisely at the communities where the slow ripple can become a real hardship. For an ordinary household, the guidance here is mostly steadiness rather than action. There is no need to stockpile or to fear empty shelves in a well-supplied market. The sensible posture is awareness, an understanding that some prices may drift up over the coming year, and that the reason traces back to weather half a world away, not to anything amiss close to home. For those in exposed farming regions, the real preparation runs through the official agricultural and water advisories, the same trusted channels that carry every other piece of El Niño guidance. So the slow ripple completes the journey, carrying a shift in the Pacific all the way to the kitchen and the market, gently in most places and harder in the exposed ones. Having traced where this event reaches, the natural next question is what any of us can actually do about it. The plain standard guidance for meeting an El Niño well is where we turn next. After 2 hours of tracing where this event reaches, the fair question is a simple one. What does a person actually do with all of it? The answer is calmer and more ordinary than the scale of the pattern might suggest, because preparing for an El Niño is not a special art. It is the same steady readiness that serves any season, taken a little earlier and aimed at the risks the forecast has flagged for your particular corner of the world. The first and most important step is to know your own risk, since El Niño affects different places in opposite ways. The single most useful thing anyone can do is find out which side of the pattern they live on, the dry side or the wet side, the storm side or the heat side. Your National Weather Service publishes seasonal outlooks that translate the global pattern into a local lean, and that local lean is what should guide your preparation. A person in a drought-prone region prepares very differently from a person in a flood-prone one, and the broad story of El Niño matters to you mainly through that local translation. For those on the dry side, the preparation centres on water and fire. Treat water as the precious resource it becomes in a lean season, and conserve early rather than waiting for restrictions. If you farm, talk with local agricultural advisors about choices suited to a drier year. In fire-prone areas, clear what you safely can around your home, and learn the local warning system before the dangerous months arrive. None of this is dramatic. It is the quiet, early diligence that turns a hard season into a manageable one. For those on the wet side, the focus shifts to flooding. Learn whether you live or work on low ground, near a river, or below a slope that could give way under heavy rain. Heed flood watches and warnings from your weather service, and never enter floodwater on foot or in a vehicle, since it is deeper and stronger than it appears, and is a leading cause of harm in floods. Keep a few days of supplies and your important documents somewhere you can reach quickly. These are small steps that save lives in exactly the season the odds now favour. A few cautions cut across every region. In a year tilted warmer, take heat seriously, drink water, seek cool space in the hottest hours, and check on the elderly, the very young, and outdoor workers who bear heat the hardest. In storm country, prepare as you would in any year regardless of the seasonal forecast, because a quiet season still takes only one storm. And everywhere, get your information from official sources, your National Meteorological Service and disaster agencies, rather than from rumour or alarming posts that strip away the careful uncertainty real forecasters keep. There is one more piece of guidance that is less about supplies and more about mindset, and it may be the most useful of all. Hold this event with steadiness. El Niño is a known, studied, forecastable pattern, not a mystery and not a catastrophe bearing down. It shifts the odds, it gives months of warning, and it has been met successfully many times before. The right response is neither to dismiss it nor to fear it, but to prepare sensibly for the lean the forecast shows and then to get on with life, checking the outlook as it updates. Calm preparation is what the whole machinery of forecasting exists to enable. That machinery does not stop now that the advisory is out. The forecast will keep sharpening as the event builds, and there are specific signals worth following in the months ahead, along with a clear schedule for when the next official word will come. Knowing what to watch, and when, is the practical close to this report, and it is where we turn next. The story does not end with the advisory. An El Niño is a moving event, and the forecast keeps sharpening as it builds, so the sensible thing is to know what to watch, and when the next reliable word will come. The good news is that following this pattern does not require expert tools. It requires knowing a few signals and a simple schedule, and then checking in rather than worrying in between. The most useful thing to follow is the monthly update from the forecasters themselves. The United States Science Agency issues an official discussion of this pattern once a month, on a set schedule, and that update is the single best source for whether the event is strengthening as expected, holding steady, or surprising anyone. International bodies issue their own updates on a similar rhythm, and they tend to agree. Marking those monthly updates and reading the plain language summary is more valuable than tracking daily wiggles, because the month-to-month view is where the real trend lives. If you want to watch the ocean directly, the number to follow is the one we have leaned on throughout, the temperature of that central Pacific zone against its average. As the year goes on, watch whether the patient 3-month version of that number keeps climbing toward the strong and very strong thresholds, or whether it levels off. A steady climb through the fall would confirm the forecast of a strengthening event peaking in winter. An early levelling would hint at something more modest. Either way, that single number is the pulse of the whole pattern. There are a few supporting signals worth a glance for anyone who wants a fuller picture. Watch whether the trade winds stay weak, since their easing is what sustains the warm phase, and a return of strong easterly winds would be an early sign the event is losing steam. Watch the pressure seesaw across the Pacific that tracks the atmosphere's cooperation, and watch the deep ocean warmth, the subsurface fuel tank, since a well-stocked reservoir supports further strengthening while a draining one signals the coming fade. None of these require special access. Forecasters report them in plain terms in their monthly discussions. The calendar of the event itself is the simplest thing to hold. The pattern is expected to build through the rest of the year, reach its peak strength around the turn of the year, and then begin to fade through the following spring. The strongest effects on weather should cluster around that winter peak, and the largest mark on global temperature may lag into the year after, so the months to watch most closely are the late fall and winter, when the event should be at full force, and the following year, when its temperature signature should crest. Knowing that rough timeline tells you when each part of the story is due, a word on uncertainty belongs here too, because watching honestly means watching for the chance of being wrong. The spring barrier that clouded the early forecast eases as the year goes on and the pattern commits, so confidence in the strength and timing should grow with each monthly update. But surprises remain possible. The event could strengthen faster or slower than expected, peak earlier or later, or settle a notch below the top tier. Watching the monthly updates is exactly how you catch such a turn early, which is far better than assuming the first forecast was the final word. For most people, the practical version of all this is short. Check the monthly outlook from your National Weather Service, pay attention as the late fall and winter approach, and follow any local seasonal forecast that tells you which way your own region is leaning. That is enough to stay genuinely informed without drowning in detail. The forecasters do the hard watching. Your job is only to check their work as it updates, and to act on the local guidance that flows from it. That brings us to the close, where it is worth gathering the whole event into a few clear lines, separating firmly what is known from what is not, and naming the single most important thing to watch from here. The final accounting of where this El Niño stands is where we end. So where does it stand? After 2 hours of following one warm patch of ocean across the world, it is worth gathering the whole event into a few clear lines, and being honest about the difference between what is settled and what is still open. That separation is the most useful thing to carry away from a report like this. What is known is solid. El Niño has formed in the tropical Pacific, confirmed by an official advisory earlier this month. The central Pacific is warmer than normal, and growing warmer, the trade winds have eased, and the ocean and atmosphere have coupled into a single self-sustaining pattern. This is not a forecast. It is an observation, measured by buoys and satellites, and agreed upon by every major forecasting centre in the world. The warm phase is here, and it is real. What is forecast carries strong support but honest limits. The event is expected to strengthen through the rest of the year, peak around the turn of the year, and then fade through the following spring, with a real chance, close to 2 in 3/1 measure, of reaching the top very strong tier. That outlook is shared across independent forecasters, which is why confidence is high. But it was issued during the season that earns a little extra doubt, so the exact peak strength and timing remain genuinely uncertain, and the event could yet land a notch softer than the headline odds suggest. What is uncertain, finally, is the precise local toll, and that uncertainty is permanent rather than a gap to be closed. El Niño shifts the odds across whole regions over whole seasons. It tilts one belt of the world toward drought and another toward flood, quiets the Atlantic storms while stirring the Pacific, stresses the reefs and the fisheries, and presses on harvests and water and prices, most heavily in the places already stretched. But every one of those is a raised risk, not a promise, and every El Niño is unique. The pattern loads the dice. It never decides the single roll. Above all of it sits the one thing worth remembering when the rest fades. This event matters most not for what it is but for where it is landing. A natural warm phase, no stronger than others before it, is forming on a planet already running at record warmth, and that overlap raises the odds that the coming year or two will reach new highs in global temperature, very possibly beyond anything yet measured, with the largest mark likely lagging into the year after the peak. The cycle has not changed. The floor beneath it has risen, and this event is a preview of where that rising floor is heading on its own. The single most important thing to watch from here is straightforward. Follow the monthly updates from the forecasters as the late fall and winter approach, and watch whether that central Pacific warmth keeps climbing toward the strong and very strong thresholds or levels off. That one trend will tell you, more than anything else, how the rest of this story unfolds, and follow your own National Weather Service for the local lean, because the global pattern reaches you through that local translation and nowhere else. There is no need to end on alarm, because alarm was never the right response to this. El Niño is a known, studied, forecastable pattern, met successfully many times before, and it gives months of warning precisely so that preparation can be calm and early, rather than frightened and late. The serious part, the warm phase landing on a warming world, is sobering enough stated plainly, and stating it plainly is how it stays useful. Watch the ocean, follow your local outlook, prepare sensibly for the lean your region faces, and check back as the picture sharpens. That is where this El Niño stands today. The ocean has tipped into its warm phase, the world's weather is leaning to match, and the months ahead will show how far it goes. We will keep watching it here, calmly, and report what changes as it does. Until the next update, take care and keep an eye on the sky.